Hello everyone, my name is Araceli and I'm here to talk to you today about space agriculture. This field supports efforts for crew travel into deep space by enabling a sustainable method of food production. But that's not all. These efforts have made significant contributions to Earth agriculture and consumer advancements. In this presentation, I will discuss the basics of space agriculture, several key challenges, provide some examples and practical applications, outline the future outlook of space agriculture, and discuss how space technology connects with Earth agriculture. To begin, what is space agriculture? Space agriculture refers to the process of growing plants in space as a means of food production. This field supports the sustenance and survival of crew members aboard space stations and enhances their psychological well-being. There are several key challenges with space agriculture. Technologies that enable space agriculture must address microgravity, which can cause water and nutrients to distribute unevenly, causing harm to plant growth, resource scarcity, which is the need for compact quote-unquote fields aboard travel vessels, and finally, the future of plant genetics. We are currently unsure of the effects on future generations grown from spaceflight affected plants. There are several practical applications and real-life examples that I would like to highlight during this presentation. First, NASA's Advanced Plant Habitat. This habitat is a fully enclosed growth chamber aboard the ISS. This habitat has produced viable, edible crops, the Hutch chilies, which were reportedly delicious. Crew members were also benefited by the mental health benefits of tending to and harvesting crops. Additionally, NASA has produced the vegetable production system, which allows astronauts to grow and consume fresh produce aboard the ISS. This technology uses plant pillows constructed with Teflon and Kevlar, which combat issues caused by microgravity. There are many advancements that can be made with space agriculture, but there are three I would like to highlight. First, genetic selection. This influences not only space agriculture, but in Earth agriculture as well. Researchers are collaborating to engineer plants that allow for year-round harvests. This can increase the quantity of food produced year-round. Looking further to the future, NASA has plans to conduct experiments related to agriculture on Mars. The experiments aim to determine how to germinate and grow seeds in Mars' toxic soil. There's also accelerated growth research, which has concluded that there is a specific type of airborne fungus that accelerates plant growth in a safe manner. Finally, I would like to discuss the impact on Earth agriculture. Several technologies currently have made significant changes for Earth farmers and food production supply chains. For example, leaf sensors were originally designed to monitor plant hydration in orbit, and they are now used by Earth farmers to determine when crops need water. There's also aeroside technology, a means of food preservation that scrubs ethylene gas from spacecraft or food storage air, reducing rotting rates. Finally, there are several space technologies that have influenced advancements for consumer technologies and other technologies on Earth. First, automated farming, self-driving tractors and automated harvesters rely heavily on GPS systems deployed for space navigation and tracking originally. There's also plant growth lighting, which has helped greenhouse operations and vertical farming on Earth by using lighting systems perfected for photosynthesis. Consumer technology has also adapted the lighting and plant habitat technologies, with one example, AeroGrow, being a direct descendant of NASA's compact habitat engineering. Thank you for your time today, and I hope you enjoyed my breakdown on the topic of space agriculture, as well as the examples I provided to help you visualize the science.